Hello students, let us read this problem. This is the problem on work energy principle. A block of mass 20 kg is released from rest on a top of an inclined plane at A. It travels on inclined plane and comes to rest at point C. Find the distance x it travels, right? Now that the distance x is between B and C. This is distance x it travels and its maximum velocity attained during motion. Take coefficient of kinetic friction as 0.3. Now please remember that in work energy principle problem, every problem can be solved by writing down a single equation. Now let's understand what is the situation here. Block A will slide from A to B and from B to C. It starts from rest at point A, but because it is on an inclined plane, because of gravity, it will come down. And you are asked to find out what is the maximum velocity attained by the block and what is the distance between B and C. The block stops at C. Now it starts from A with zero velocity, goes to C, again its velocity is 0. Now you are asked to find out maximum velocity. Now think about it, something is falling down, here it is on inclined plane, but if you just drop a ball from certain height, the ball as it comes down, its velocity will keep on increasing and it will reach its maximum velocity just before hitting the ground, right? So as it comes down, its velocity increases. Similarly here, the block, when it slides down, its velocity will keep on increasing and at B it will have maximum velocity. You want to find out maximum velocity and you want to find out the distance x. So let's first find out maximum velocity, that means velocity at point B. So we want to find out, let's say VB. We want to find out VB. So in order to find out VB, let us apply the work energy principle between point A and B, right? So at point, so what is the work energy principle? Let me write down that equation. We'll say that potential energy at A. Now when you say energy at A, the body will have potential energy. So let me write mgh, this is potential energy at A, plus kinetic energy at A, that is half mv square. So I'll write VA, VA half, I'm sorry for this. Let me clear this. So this is, okay, so half mv square, all of this at point A, right? Plus work done, if there is any external force, right, into the distance, that is work done. Is there any work? So we'll come to that later. So work done minus frictional energy. So I will write frictional force into the distance traveled, that is minus frictional energy. This will be energy at point B. So I am applying work energy principle between points A and B. So energy at B will also be potential energy. So again I made mistake. I should write this in. So I'll write this as mgh at B plus kinetic energy is half mvb square, right? Of course here there can also be spring energy, but there is no spring here. So in the general equation, along with potential and kinetic energy, you have to add spring energy also, but there is no spring in this diagram, so you don't have to bother about spring energy. So please note the equation. Energy at point A, this is your point A, plus work done on block A, that is energy supplied, work done is energy supplied, minus frictional energy when it moves from A to B, will be equal to energy at B, law of conservation of energy, right? So this is what we have applied basically. So now let's if you apply this, let's put the values and you should get the answer. So mgh, so what is, so point A, that is potential energy. So at what height is this block A from the baseline? This is the, BC is on the, that's the ground. So this height, you have to find out this height, this is h. And you can immediately see this is 30 degrees, this h is opposite side. So h by 12 is equal to sine 30. So h is equal to 12 sine 30. Okay, so you can write h is equal to 12 sine 30, m is 20, and let's take g is equal to 9.8. So I'll write this as mgh as 20, 9.8, h is 12 sine 30. Okay, right. Now, what about kinetic energy? This is your half mva square. But starting from rest, so there is no kinetic energy. So this is gone, right? This is gone. Is there any external work acting on block A, a 20 kg block at point A? No, there is no external work. So there is no force. So this work done is gone. Minus frictional force. Now let's find out frictional force. Now see, if you want to find out frictional force, frictional force is equal to, frictional force is equal to mu into n, right? So let me clear this. Now if you see here, this is the block, its weight is 20 mg, is 20 into 9.8, which is acting 20 into 9.8 newtons. It is acting downward. The normal force is this, right? So if you want, I can make a just to distinguish it, I'll use blue color. So this is N, right? And we know frictional force when it block is coming from A. This is A, right? It's starting from, so this is point A to B. It's coming from A to B. So frictional force acting from when the block slides from A to B, that frictional force is, let's say, Fr is equal to mu into N. Now what is N? We want to find out N. You can see that this angle is 30. So obviously this angle, this is also 30, right? This angle is also 30 degrees. So I'll write, so you can, if you see that if this is a plane, this is say y, and the plane is x. So resolve the forces on block along y direction. So I'll write that, and the block, resolve it in the sense the block is not moving in y direction. Why I am taking y is this, y perpendicular to the plane. So I can say sigma Fy is equal to 0 to find out n. Why? What we are doing? To find out n. So this angle we have said is 30. So resolve the force 20 into 9.8 into cos 30. 20 into 9.8 into cos 30. This is downward, so I'll make it minus, plus n, because n is upward, right? This is n upward, is equal to 0. So you get n is equal to 20 into 9.8 into cos 30, right? Right. So this is n. Now friction. So if this is n, then you can say friction is, this is what is frictional force. It is mu into n. So it is 20 into 9.8 into cos 30. Sorry, let me correct it. Mu into n, right? So I'll write this as frictional force is equal to mu is 0.3 into n is, this is our n, 20 into 9.8 into cos 30. So I'm writing this expression, Fr into d. Fr is frictional force, which is, we have written this frictional force is 0.3 into 20 into 9.8 into, here we have to write cos 30. Let me make it clear. 20 into 9.8 into cos 30 this is mu n into the distance. What is the distance? It is moving from A to B, so it is 12 meters. It is 12 meters, right? This is equal to, what is the mgh? Please note this mgh at B, right? Mg at B it has come down, so there is no potential energy, and we want to find out. So potential energy is 0 plus we want what is the kinetic energy at B. So kinetic energy is half. This is what I am writing. Please note this is half 20 m is 20 VB square, right? So this is the equation. So you can see this is the equation. The only unknown is VB, and when you find out VB, this VB will be equal to 7.52 meters per second, right? 7.52 meters per second. Now this is what we have found out. This is your maximum velocity. So your one answer is, we have found out the answer. Okay. After you have found out this answer, let's now go to find out the distance traveled x. Okay, we want to find out the distance traveled x. So to find out that, we will write now energy equation. Please note, we will write energy equation between point B and C. Between point B and C. Okay. So energy equation between point B and C. Work energy equation. Actually, I should write work energy equation. Work energy equation between B and C. Okay. So again, at B we can say potential energy. So we'll write mgh at B plus half m VB square, right? Sorry, I should VB square. Yeah, this is okay. This is kinetic energy plus work done. So which will be force into distance, right? If there is any work done. Sorry. Now, so between B and C. So work done. Yes, F into B minus frictional force into the distance traveled, right? This will be equal to energy at point C. Again, it is mgh at C plus half m VC square. That is your kinetic energy. Right? Now please note, between B and C are at the same level. So their potential energy is same. So mgh at B is equal to mgh at C. So I have cancelled it out. Then half m VB square, right? Half m VB square, I can write half into 20. Velocity at B we have found out 7.52 meters. That we have found out. Now is there, the block is now, C block has come at point B. Is there any force acting, external force acting on B? No. So work done is 0. So this F into D is gone. Frictional force, obviously there is going to be frictional force, and that frictional force is mu into N. And so we have to find out now normal force. Please note, now the block is at a horizontal plane, right, at point B. So the normal is going to be weight of the block. Can you see that? So this is weight is acting, this is N, this is the weight 20 into 9.8. So weight acting downward, so normal force is equal to weight. So I'll write, there is earlier it was normal force had to consider cos 30. So now there is no need. So now we will say frictional force is equal to minus, please note, frictional force is equal to is mu into N. Mu is 0.3. N is the weight of the body, it is 20 into 9.8, right? Into the distance traveled, that is x, right? So, and then is there a kinetic energy at point C? No, because the body has come to halt there. The body has zero velocity. So this is 0. Now you can say that, if I'll clear this, in this equation, the only unknown is x, and if you calculate, you should get x is equal to 9.6 0.61 meters, right? That's your second answer. Thank you.